The theorems always go fine eventually, but it's hard to start. So I figured, well, let's walk you through this. It's not due until Wednesday. Hopefully you can get a good start following along with this video and then have maybe some better questions tomorrow. Notice you can write on this digitally. There's kind of a lot, and I wanted you to have the data in here. Okay. A toy car travels on a straight path. In calculus AB, it's always a straight path because we only do one-dimensional motion. Okay. During the time interval for 0 to 60 seconds, the toy car's velocity, you can think speed, measured in feet per second, is a continuous function. So already I'm thinking intermediate value theorem asks me to prove something true, and that function needs to be continuous. So I think I'm going to write, before I do anything else down below, v of t is continuous. Just so I don't forget. That's an important prerequisite for using the intermediate value theorem. Okay. So selected values are given below. Whenever I'm given a table of values, I don't really worry about what's in there. I'm going to read the question and then come back and decide what I need to do. I like blue better than black. Okay, for 0 to 60, must there be a time when velocity is equal to negative 2? Okay, and so really what we're looking for a velocity. Maybe that's not the right way to say it. We're looking for where the velocity is less than negative 2 and another time where the velocity is more than negative 2. Again, I think it's easiest to see that on a sketch. Okay, so at 0, the velocity is negative 10. At 15, the velocity is negative 15, so lower. Doesn't matter where that is. At 25, the velocity is back to negative 10 again. And we want to know if the velocity is ever equal to negative 2. And kind of like the elevator thing in class, you know, so far, the velocity graph could have crossed negative 2, but we haven't seen one velocity more than negative 2 and another velocity less than negative 2. So I guess that's what I'm on the lookout for as I'm plotting these data points, right? Because negative 10 and negative 15 are both less than negative 2. We're looking for a place where the velocity changes from being less to above negative 2. Okay, so at 30, we get negative 7. Okay, at 35, negative 5. Okay, so this graph still might have crossed, but we don't know. And then at 50, we get 0. Okay, and then now we're done. Okay, we don't need to look any farther. Because this graph is continuous, maybe it follows this nice smooth path. Maybe it doesn't. But between 35 and 50, the graph went from being less than negative 2, namely negative 5, and more than negative 2, namely 0. Okay. So that's really what I see. I think normally, and farther in the year, you'd just be looking at that table of values, but sometimes it's kind of hard to see. Okay, so v of t is continuous, and now I'm just going to continue writing. Where is it continuous? Well, it actually is continuous on 0 to 60, but I am going to say 35 to 50, because that's the interval where I found that the velocity was less than negative 2 and then more than negative 2. You could also just do 0 to 60, because that's true on the whole thing. Okay, and in fact, 0 to 60 would work, because notice, when time equals 0, the velocity is negative 10. That's below that negative 2. And then at 60, the velocity is 13, more than that negative 2. So we could have done that as well. Okay, I'm not going to. Velocity is continuous on 35 to 50, so intermediate value theorem applies. Okay, and then I will say v of 35, which is negative 5 is less than negative 2, and v of 50, which is 0, is greater than negative 2. And maybe it would help if I kind of had parentheses, because I'm saying negative 5 is less than negative 2, but I'm telling where it came from. Right? So I'm just describing the graph. I found a place right here. V of 35 is less than negative 2. V of 50 is greater than negative 2. And then I'm going to say, so V of t must equal negative 2 between t equals 35 and t equals 50. The way I guess I would normally write that is not the words, but I'm assuming you might need help. Normally I would write V of t equals negative 2 on the open interval 35 to 50. Right? You could also write 35 is less than t is less than 50. I'm going to erase that last one. Okay, if that helps, try to do the next one without me, but if not, here we go. So here it says use intermediate value theorem to show there must be a solution to the given function on the given interval. Now, weirdly, people will often think, well, if I find where cosine of x is equal to x, then I've proven this. And that, that's true and that's normal life, but we definitely have to use the intermediate value theorem. Okay, so cosine of x equals x on 0 to 1. So, well, you should know the graph of cosine looks like this, and cosine is continuous. X is continuous, right? Because that's just the line, y equals x. And so I'm just going to rearrange. I'm going to have y, how do I do that first? Probably say 0 is equal to cosine of x minus x. Okay? And then I will say f of x, and this is a whole lot like the one we did in class, is equal to cosine of x minus x. I don't exactly know what cosine of x minus x is, and maybe it makes sense for you to graph that on Desmos or your graphing calculator, but I think it might make more sense if we look at that afterwards. Okay? Because basically I don't know what cosine of x minus x looks like. I don't know. I wouldn't be surprised if it has some wiggles. Okay? But what I'm trying to decide is, does this graph go above and does this graph go below the x-axis? Because then if it does, it will be equal to 0 across the x-axis. Okay. So I'm not really sure what to do, so maybe I just do f of 0. That's cosine of 0 minus 0. So f of 0 is 1 minus 0, which is 1. Okay. And then I'll do f of 1 equals cosine of 1 minus 1. Now that's harder because 1, negative 1. Normally thinking about the cosine graph, we think about, well, cosine of 0 is 0, cosine of pi halves is 0, and we don't normally use numbers like 1. Okay, but what you can be certain of is 1 is between 0 and pi halves, which means cosine of 1 is less than 1, which means f of 1, cosine of 1 minus 1, is less than 0. Right? Because you're taking, I don't know, whatever this y value is, cosine of 1, doesn't matter what it is, and subtracting 1, and so you're going to get a negative. So that's another weirdness that hopefully you'll get used to. This must be negative, even though we don't know a decimal for cosine of 1. I do have a student this year, Constance, and she's like, this is going to make more sense if you have like the words that you're saying written out. So hopefully this is useful to you. Okay. So what I have found is a couple of things. I found f, some graph. Don't even think, maybe a good thing to think right now is don't worry about what function it is. I'm just going to cross this off and delete it. Okay. I don't know what it is, but f of 0 was positive. Oh, shoot, that was the wrong word. F of 0 is 1. F of 0 is above the x-axis. And f of 1 is negative, below the x-axis. So what's going to happen if you have something above the x-axis and below the x-axis? Well, it should cross the x-axis if that function's continuous. Dang. Again, that's kind of a hard question. Is y equals cosine of x minus x continuous? It is. And the reason being is cosine is a continuous function, x is a continuous function, and subtraction is continuous, or subtraction doesn't create problems the way division does. So I'll say, cosine of x minus x is continuous on the closed interval 0 to 1. So the intermediate value theorem guarantees f of x must equal 0 between x equals 0 and x equals 1. Okay. Now, how to use your calculator to find the actual solution value. Okay, so here's my graphing calculator, and I am going to type in what I had before. Oh, shoot, I forgot to tell you. Make sure you are in radian mode. Okay. So y equals, and I'm going to do cosine of x minus x. Pretty sure that's what we were graphing, right? Cosine of x minus x. Okay. And then in here in the window, my x minimum, I'm going to do negative 0.1. And then x maximum is 1.1. As far as y minimum and y maximum, I'm talking about sine and subtracting 1. So I think negative 1 to 1 looks good. Okay. So this is the graph of cosine of x minus x from 0 to 1. And so what we had previously said is, we can do calculations. So now, at x equals 0, cosine of 0 minus 0 is 1. And we can do that again at 1. Value, x equals 1, enter, and we get, okay, negative 0.459. Remember when I was talking before, that's this value right here. We don't know how big that was. We just knew that it was negative. Okay, so it does say that we want to find, where was it? Right, we tested our hypothesis. We showed numeric evidence. That was these parts right here. F of 0 is 1 and f of 1 is negative. And we wrote our concluding statement. That's down here. Now we're going to use our calculator to find the actual solution value correct to 3 decimal places, even though that's not an intermediate value theorem thing normally. And there are 2 ways to go. One way to go is use the graph. If you have an 84, do that. That's calculations here, second calc. And we want to find, we want to find a 0. Because right now on this graph, we're looking for where the graph crosses the x-axis. So left bound, you need to get that cursor to the left of this little spot that we're looking for. And then I'll press enter. Right bound, get that to the right of where we're looking for. Press enter. And now notice you have these 2 little arrows. The 83s will too. Like, hey, I'm only looking between here. And it's asking for a guess, like a starting value. And so you press enter, and we'll write down 0.7390851. Okay, hope that helps.